Stop whatever you're doing. Because the reason you feel exhausted after every meal, the reason your digestion is a disaster, the reason your belly won't shrink no matter what you try, has nothing to do with willpower and everything to do with three organs your doctor almost never talks about until they're already failing: your liver, your gut, and your kidneys. Listen to this. Right now, non-alcoholic fatty liver disease affects over 100 million Americans, making it the most common liver condition in the United States. Chronic kidney disease quietly damages over 37 million Americans, and most of them have no idea. And gut disorders, from IBS to leaky gut to dysbiosis, affect an estimated 70 million Americans every single year, costing the healthcare system billions. 3 organ systems. 3 silent epidemics. All accelerating at the same time. And here's what should genuinely stop you in your tracks. Japan. A nation of over 125 million people, has among the lowest rates of liver disease, kidney failure, and gut-related illness in the entire developed world. Japanese adults routinely outperform Western adults in liver enzyme profiles, kidney filtration markers, and gut microbiome diversity metrics in every major comparative study that has measured them. Not because they have superior genetics. Japanese Americans living Western lifestyles develop the same organ diseases as other Americans. The difference is the daily habits. 25 of them. So if you want your liver filtering cleanly, your gut barrier intact, and your kidneys running at full capacity, not at 70, but starting now, these are the 25 Japanese habits that science confirms protect all 3 simultaneously. Let's count them down. The very first habit Japan practices every single morning, before coffee, before food, before anything, is drinking 1 to 2 glasses of warm water. And what this does to your liver and kidneys in the first minutes of the day is physiologically significant. Your liver processes over a liter of blood per minute. Overnight, it has been working, conjugating metabolic waste, neutralizing hormonal byproducts, packaging toxins for biliary excretion. By morning, it is ready to release that accumulated waste into the bile duct and onward into the digestive tract. Warm water is the physiological trigger that initiates this release. It stimulates bile flow, activates peristalsis in the intestines, and begins flushing the overnight accumulated waste before any new food load enters the system and competes for digestive priority. For the kidneys, morning hydration is equally critical. Your kidneys filter approximately 180 liters of blood per day, producing about 1.5 liters of urine. During sleep, urine becomes increasingly concentrated, creating a higher solute environment in which kidney stones, uric acid crystals, and bacterial growth become more likely. Warm water in the morning immediately dilutes this concentration, protects the tubular membranes of the kidneys from solute damage, and reinitializes the filtration cycle. A 2020 review in the Journal of Nutritional Science confirmed that morning warm water intake significantly improved intestinal motility and waste clearance in healthy adults. Japan doesn't call this detoxing. They call it waking up. Miso soup. At breakfast, at lunch, sometimes at dinner. Japan consumes miso soup with a frequency that has no Western equivalent, and the reason this matters for gut health is rooted in what miso actually is and what it does to your intestinal lining. Miso is fermented soybean paste, a living food produced through months of microbial fermentation by Aspergillus oryzae mold and Lactobacillus bacteria. The fermentation process generates not just probiotic cultures but also bioactive peptides, free amino acids, and organic acids that directly support the health of the mucosal lining of the gut. That lining, a single-cell thick barrier that separates the contents of your intestines from your bloodstream, is the most important physical defense your body has against systemic inflammation. When the gut lining is compromised, a condition increasingly called intestinal hyperpermeability or leaky gut, lipopolysaccharides from gut bacteria cross into the bloodstream, triggering the liver's Kupffer cells to mount inflammatory responses that, sustained over time, drive non-alcoholic fatty liver disease. Japan's daily miso consumption delivers live probiotic strains and short-chain fatty acid precursors that feed colonocytes, the cells lining your colon, maintaining barrier integrity before it can be breached. Research from Japan's National Cancer Center found that miso consumers had significantly lower rates of gastric disease and maintained healthier gut microbiome profiles into late age than non-consumers. The gut lining doesn't repair itself dramatically. It repairs itself daily, and miso is Japan's daily repair tool. Green tea. Not as a trend. As Japan's primary daily beverage, consumed multiple times per day, from morning through the afternoon. And one of the most comprehensively studied hepatoprotective substances in nutritional biochemistry. Your liver detoxifies in 2 phases. Phase 1 uses cytochrome P450 enzymes to break fat-soluble toxins, environmental chemicals, drug metabolites, hormonal waste, into intermediate compounds. Phase 2 then conjugates those intermediates with water-soluble molecules so they can be excreted through bile or urine. The problem is that Phase 1 can outpace Phase 2, leaving reactive intermediate compounds accumulating in liver tissue, compounds that are often more toxic than the original substance. Supporting Phase 2 is one of the most critical and most underappreciated strategies for liver health. EGCG, the primary catechin in green tea, powerfully activates NRF2, the master transcription factor that switches on Phase 2 detoxification enzymes including glutathione S-transferase, NAD, P. H-quinone reductase, and UDP-glucuronosyltransferase. These enzymes are the liver's Phase 2 workforce. A meta-analysis published in the International Journal of Food Sciences and Nutrition found that green tea consumption was associated with significantly lower liver enzyme levels, ALT and AST, the biomarkers doctors use to assess liver cell damage. Japan drinks green tea throughout the day, delivering a continuous, sustained activation of the liver's own internal cleanup machinery. That's not a supplement protocol. That's a culture. Daikon radish. Grated alongside grilled fish, sliced into soups, pickled in vinegar, or eaten raw at the start of a meal. And the biochemical reason Japan pairs daikon with rich, cooked, or fatty foods is one of the most elegant examples of intuitive dietary medicine in any culture on earth. Raw daikon contains 3 distinct digestive enzymes, diastase, which breaks down starches, esterase, which cleaves ester bonds in fats, and amylase, which further processes complex carbohydrates. These enzymes directly supplement your own digestive enzyme output, reducing the burden on your pancreas and stomach and preventing the partial digestion that allows food particles to putrefy in the intestinal tract. Putrefaction in the gut produces ammonia, scatol, indole, and hydrogen sulfide, compounds that are directly toxic to the kidneys when absorbed and reabsorbed through the portal circulation. But here's what most people don't realize about daikon and the liver specifically. Raw daikon contains glycosylates, sulfur-containing compounds that, when metabolized by micropsia's enzymes in the radish and your gut bacteria, produce isothiocyanates. Isothiocyanates are among the most potent known activators of liver Phase 2 detoxification enzymes. A study published in the Journal of Agricultural and Food Chemistry documented that daikon-derived isothiocyanates significantly induced glutathione synthesis in hepatocytes, liver cells, at concentrations achievable through normal dietary intake. Japan has been using daikon as a digestive and hepatic support food for 1,000 years. Science now confirms the biochemical precision behind that cultural instinct. Seaweed. Wakame in the miso, nori wrapping the rice, kombu simmered into the broth, hijiki in the salad. Japan incorporates seaweed into nearly every traditional meal, and the reason this is transformative for gut health is buried in a class of compounds that most Westerners have never heard of. Seaweed polysaccharides, including alginic acid, fucoidan, laminorin, and carrageenan, are among the most complex and least studied prebiotic fibers in the human diet. Unlike the inulin in garlic or the pectin in fruit, seaweed polysaccharides require highly specialized bacterial enzymes for fermentation, enzymes found in abundance in the gut microbiomes of regular seaweed consumers, and significantly less abundant in Western microbiomes. This creates a virtuous cycle. Eating seaweed selects for the bacteria that can digest seaweed, and those bacteria produce short-chain fatty acids, butyrate, propionate, and acetate, that feed the gut lining, regulate immune function, and reduce intestinal inflammation. For the kidneys, alginic acid in seaweed performs a specific and remarkable function. It binds heavy metals including lead, mercury, cadmium, and strontium in the digestive tract, preventing their absorption into the bloodstream and escorting them safely through the colon for elimination. Research published in Environmental Health Perspectives confirmed that alginic acid chelation significantly reduced blood lead and cadmium levels in animal models exposed to heavy metal contamination. Your kidneys are responsible for filtering heavy metals from the blood, a burden that, in the modern environment, is significant. Seaweed reduces that burden before it ever reaches the renal tubules. Natto. Fermented soybeans consumed most commonly at breakfast. And their effects on the cardiovascular and renal systems are among the most clinically documented of any single food in Japan's diet. Your kidneys filter your entire blood volume approximately 30 times per day. The efficiency of that filtration, measured as glomerular filtration rate, or GFR, depends critically on the quality of blood flowing through the renal vasculature. Blood that is viscous, fibrin-rich, or laden with inflammatory protein strains the glomerular capillaries, progressively reducing filtration efficiency in the process called chronic kidney disease. Japan's natto habit addresses the upstream cause of that strain. Natto kinase, the serine protease enzyme produced during natto fermentation, has been studied in multiple clinical trials for its fibrinolytic activity. Its ability to dissolve excess fibrin, reduce blood viscosity, and lower the thrombotic burden in the circulatory system. Research in clinical hemorrhology and microcirculation found significant reductions in red blood cell aggregation and whole blood viscosity following natto kinase consumption. Cleaner, less viscous blood is blood the kidneys filter more easily and with less mechanical stress on the glomerular membranes. And natto's vitamin K2 as -7 Malawi in quachas simultaneously removes calcium deposits from renal arterioles, the small arteries feeding kidney tissue, protecting against the vascular stiffening that accelerates kidney aging. Japan eats both compounds at breakfast, every morning, for an entire lifetime. Hara Hachibu, the Okinawan practice of eating until 80% full. And while this habit appears in almost every discussion of Japanese health, its specific protection of liver, gut, and kidney function is rarely explained at the mechanistic level where it becomes genuinely compelling. Overeating, eating beyond satiety on a regular basis, directly stresses all three filtration organs simultaneously. For the liver, excess caloric intake, particularly from carbohydrates and fats, drives de novo lipogenesis. The liver's conversion of excess nutrients into triglycerides for storage. When this process chronically outpaces the liver's ability to export those triglycerides as VLDL particles, fat accumulates in hepatocytes, the initial stage of non-alcoholic fatty liver disease. For the gut, overeating stretches the intestinal wall, disrupting the tight junction proteins that maintain gut barrier integrity. For the kidneys, chronic overeating drives hyperinsulinemia, which activates the renin-angiotensin-aldosterone system, increasing glomerular pressure and accelerating nephron loss over time. Stopping at 80% prevents all three cascades. The liver is not overwhelmed with excess substrate for lipogenesis. The gut wall is not chronically overstretched. And insulin remains in a range that does not hyperstimulation renal hemodynamics. The Okinawa Centenarian study found that elderly Okinawans consumed roughly 10 to 15% fewer calories than mainland Japanese, yet maintained lower liver enzyme profiles, lower serum creatinine, and better gut motility scores into advanced age. That small daily gap, 3 times a day, for 70 years, protects 3 organ systems simultaneously. That is not a diet. That is biology. Tsukamoto, Japan's traditional fermented and pickled vegetables. At virtually every Japanese meal, something fermented is on the table. And the mechanism through which these fermented foods protect the gut, and indirectly the liver and kidneys, runs through one of the most important compounds in gut biology, butyrate. Butyrate is a short-chain fatty acid produced when your gut bacteria ferment dietary fiber, particularly the fiber found in the fermented vegetables that Tsukamoto preparations deliver alongside their live probiotic cultures. And butyrate is the primary fuel source for colonocytes, the epithelial cells lining your colon. Without adequate butyrate, colonocytes become energy-starved, tight junction proteins between cells loosen, and the gut barrier begins to fail. This allows bacterial endotoxins, lipopolysaccharides, or LPS, to cross into the portal circulation and arrive directly at the liver. LPS in the portal circulation is the primary driver of Kupffer cell activation in the liver. The inflammatory response that, when chronically triggered, drives non-alcoholic steatohepatitis, the progressive inflammatory form of fatty liver disease. A landmark Stanford study in Cell confirmed that a high-fermented food diet significantly increased microbiome diversity and reduced 19 circulating inflammatory proteins, including those directly implicated in liver inflammation. Japan's Tsukamoto, delivered at nearly every meal, maintains the butyrate supply that keeps the colonocytes fed, the gut barrier sealed, and the liver's inflammatory burden at the lowest possible level. Walking after meals. In Japan, a short walk after eating is cultural expectation, not exercise ambition. And what that walk does to the liver, gut, and kidneys in the 30 to 60 minutes following a meal is one of the most important metabolic interventions available, and one of the simplest. After a meal, blood glucose rises. Insulin surges to manage that glucose. In the liver, insulin signals the storage of glycogen and, when glycogen stores are full, the conversion of remaining glucose into fat via de novo lipogenesis. The higher and longer the post-meal glucose spike, the more insulin is secreted, and the more strongly lipogenic signaling is activated in hepatocytes. A 10-minute walk after eating directly reduces the amplitude and duration of the post-meal glucose spike by directing blood glucose into contracting muscle cells independent of insulin, a process mediated by GLUT4 transporters that are activated by muscle contraction regardless of insulin levels. A 2022 meta-analysis published in Sports Medicine found that just 2 to 5 minutes of walking after meals reduced postprandial blood glucose by up to 58% compared to sitting. Lower post-meal glucose means lower insulin secretion, reduced hepatic lipogenic signaling, and less fat accumulation in liver tissue. For the kidneys, lower insulin levels mean reduced activation of the renin-angiotensin system and lower intraglomerular pressure. For the gut, post-meal walking stimulates gastric motility, reducing intestinal transit time and the window in which food particles can ferment and produce toxic byproducts. Japan walks after eating not because they're trying to exercise. They walk because life is lived on foot. The liver benefits regardless of the intention. Fish over red meat. Japan consumes roughly 65 kilograms of fish per person per year, compared to approximately 22 kilograms in the United States. And the implications of this single dietary difference for kidney health are among the most clearly documented in nephrology research. Red meat, particularly processed and charbroiled red meat, produces 3 compounds that directly burden the kidneys. First, purines in red meat are metabolized to uric acid, which must be filtered and excreted by the kidneys. Chronically elevated uric acid, hyperuricemia, damages renal tubular cells and is a primary cause of both kidney stones and progressive chronic kidney disease. Second, the sulfur-containing amino acids in red meat produce metabolic acid that the kidneys must buffer and excrete, increasing the acid load on the renal tubules over time. Third, heterocyclic amines produced during high-heat cooking of red meat are nephrotoxic compounds that require renal filtration and are associated with kidney cancer risk in long-term epidemiological studies. Marine fish, by contrast, produces a significantly lower uric acid burden, generates less metabolic acid, and delivers EPA and DHA, omega-3 fatty acids that reduce renal inflammation and have been shown in research published in the Journal of the American Society of Nephrology to slow the progression of chronic kidney disease and reduce proteinuria. Japan's preference for fish is not just cultural. It is, from the kidney's perspective, the difference between an organ running on clean fuel and one burning dirty. Green tea between meals. Not just at breakfast, throughout the day. And this specific timing, consumed between food intakes when the urinary tract is not buffering a food bolus, delivers kidney protective benefits that most people consuming green tea never realize they're receiving. Kidney stones form when crystalline compounds, calcium oxalate, uric acid, calcium phosphate, supersaturate in the urine and precipitate out of solution. The primary defense against stone formation is adequate urinary dilution, a high enough daily urine volume to keep stone-forming compounds in solution. Japan's habitual green tea consumption throughout the day maintains a consistently high fluid intake that directly serves this protective function. But the EGCG in green tea does something beyond simple hydration. Research published in Urological Research found that EGCG significantly inhibited the adhesion of calcium oxalate crystals to renal tubular epithelial cells, the first step in stone formation and retention in the kidney. EGCG essentially makes the kidney's inner surface less sticky to the crystals trying to form stones on it. Additionally, research in the American Journal of Kidney Diseases found that habitual tea consumption was associated with a 13% lower risk of kidney stone formation in a prospective study of over 200,000 participants. Japan consumes green tea throughout the day, every day, without thinking of it as kidney medicine. But kidney medicine is exactly what it is. Japan's relationship with salt and sodium. And this is more nuanced than most people expect, because Japan actually has one of the higher sodium intakes globally. But the source of that sodium, and the other compounds that accompany it, make an enormous biological difference for the kidneys. The Japanese get much of their sodium from fermented condiments, miso, soy sauce, tamari, mirin, rather than from processed table salt added to ultra-processed foods. These fermented sodium sources come packaged with potassium, glutamate, organic acids, and mineral cofactors that fundamentally alter how the kidneys process the sodium load. Potassium is the critical variable. Sodium causes the kidneys to retain water and raise blood pressure, but only when potassium is insufficient to counterbalance its effects on renal tubular reabsorption. Japan's diet, rich in seaweed, fish, vegetables, and fermented foods, provides exceptionally high dietary potassium alongside its sodium, maintaining a sodium-to-potassium ratio that is far more favorable for renal health than the typical Western diet of processed foods with abundant sodium and almost no potassium. Research in the Journal of the American College of Cardiology found that it was the ratio of sodium to potassium, not absolute sodium intake, that most strongly predicted hypertension and kidney function decline. Japan eats high-umami fermented sodium with high-mineral potassium-rich foods. The kidneys process that combination with far less strain than the sodium-dominant, potassium-deficient Western diet they never evolved to filter. Mushrooms. Shiitake, maitake, enoki, heishi, incorporated into broths, sautéed as sides, steeped as teas. Japan consumes more culinary and medicinal mushrooms per capita than almost any other nation, and the hepatoprotective compounds in these fungi are the subject of a growing body of clinical research. Shiitake mushrooms contain ariadenine, a unique compound that inhibits an enzyme called S-adenosilhocysteine hydrolase, reducing homocysteine levels in the blood. Elevated homocysteine is directly toxic to liver cells and a strong independent predictor of liver fibrosis and cardiovascular disease. Shiitake also contains lentinin, a beta-glucan polysaccharide that activates Kupffer cells in an anti-inflammatory, rather than pro-inflammatory, direction, modulating rather than triggering the immune response in the liver. A study in phytomedicine documented that heishi extract produced significant reductions in liver enzymes ALT and AST in patients with chronic hepatitis. Japan doesn't supplement heishi in isolation, they simmer it into broth and eat it with rice. Hepatoprotection delivered as food is more bioavailable than hepatoprotection delivered as a pill. No snacking between meals. Japan's three-meal culture, defined eating windows separated by genuine fasting gaps, is one of the most physiologically important habits on this entire list for gut health, and one that Western eating culture has systematically dismantled. Between meals, when the stomach is empty and blood glucose has stabilized, the gut activates the migrating motor complex, a cyclical wave of powerful muscular contractions that sweep through the entire length of the small intestine every 90 to 120 minutes. This mechanism, often called the intestinal housekeeper, sweeps undigested food particles, sloughed mucosal cells, excess bacteria, and debris downward through the intestinal tract for elimination. It is the gut's primary self-cleaning mechanism. And it only operates in the fasted state. Every snack resets the clock. Every protein bar, every handful of nuts between meals, every sip of a fruit smoothie sends food into the small intestine and halts the MMC mid-cycle. In a gut where the MMC never completes its work, bacteria accumulate in the small intestinal bacterial overgrowth, or SIBO, producing hydrogen and methane gas, generating bacterial toxins that burden the liver through the portal circulation, and inflaming the intestinal wall in a way that eventually compromises its barrier function. Research in gastroenterology confirmed that adequate meal spacing is critical for normal MMC function in humans. Japan spaces its meals. Japan keeps its gut clean. These two facts are causally and directly connected. Ginger. In the soup, with the sushi, in the sauce, steeped into evening tea. Japan incorporates ginger into daily food preparation at a frequency that makes it, effectively, a daily pharmaceutical, one that science confirms acts on the liver, gut, and kidney simultaneously through a common anti-inflammatory pathway. Gingerols and shogales, ginger's primary bioactive compounds, inhibit NF-kappa B, the master inflammatory transcription factor that drives the production of TNF-alpha, IL-6, and COX-2. NF-kappa B is the molecular switch at the root of hepatic inflammation in fatty liver disease, intestinal inflammation in inflammatory bowel conditions, and glomerular inflammation in kidney disease. Blocking this single pathway simultaneously reduces the inflammatory burden in all three organ systems. For the liver specifically, research published in the World Journal of Gastroenterology found that 6-shogal, a compound produced from gingerol during cooking, significantly attenuated liver fibrosis in animal models by inhibiting hepatic stellate cell activation, the process through which the liver replaces healthy tissue with scar tissue. For the kidneys, research in renal failure documented that ginger extracts significantly reduced creatinine levels and oxidative stress markers in the renal cortex. And for the gut, ginger accelerates gastric emptying, reducing the time food spends fermenting in the stomach and small intestine and lowering the bacterial toxin burden that reaches the liver through the portal vein. 1 ingredient. 3 organs. Daily medicine disguised as a condiment. The specific combination of eating moderately and eating fiber-rich foods, and the way this combination creates what nephrologists are now calling the gut-kidney axis effect. Japan's traditional diet is exceptionally high in dietary fiber from diverse plant sources, burdock root, lotus root, edamame, bamboo shoots, leafy vegetables, seaweed, legumes, and whole grain rice. Americans average approximately 15 grams of dietary fiber per day, roughly half the recommended intake. Traditional Japanese adults consume significantly more, from more diverse sources. And the mechanism through which this fiber intake protects the kidneys through the gut is one of the most fascinating discoveries in modern nephrology. When dietary fiber reaches the colon, gut bacteria ferment it into short-chain fatty acids, primarily butyrate, propionate, and acetate. These SCFAs are absorbed into the bloodstream and exert direct anti-inflammatory effects on renal tissue. They reduce the expression of NF-kappa B in kidney cells, decrease oxidative stress in the renal cortex, and, according to research published in the Journal of the American Society of Nephrology, significantly slow the progression of chronic kidney disease in patients with established renal impairment. The gut is talking to the kidneys through the bloodstream, using SCFAs as its messenger. Japan feeds that conversation with fiber at every meal. Tofu and soy foods. The cornerstone of Japanese protein intake. And for the kidneys specifically, the choice of plant protein over animal protein is one of the most consequential dietary decisions any person can make, a fact that nephrology research has now established with considerable clarity. Your kidneys filter the metabolic waste products of protein digestion, primarily urea, nitrogen and uric acid. When protein intake is high, these filtrate compounds increase, forcing the kidneys to work harder and increasing intraglomerular pressure, the pressure within the kidney's filtering units. Over decades, chronic high intraglomerular pressure leads to glomerulosclerosis, the scarring of filtering units that is the hallmark of progressive chronic kidney disease. Animal protein drives this process significantly more than plant protein, because animal protein generates a higher acid load, a higher urea burden, and a more pronounced hyperfiltration response. Research published in the Journal of the American Society of Nephrology found that substituting plant protein for animal protein in the diet significantly reduced proteinuria, protein leaking into urine, the earliest measurable sign of kidney damage, and slowed GFR decline in patients with chronic kidney disease. Additionally, soy isoflavones have been shown to have direct renoprotective effects. A meta-analysis in phytotherapy research found that soy isoflavone supplementation significantly reduced serum creatinine and blood urea nitrogen levels in chronic kidney disease patients. Japan eats tofu as a staple. The kidneys notice the difference every single day. Early, light dinners. Japan's traditional household finishes dinner between 6 and 7 p.m. And this timing, aligning the last meal with the early evening hours and allowing a 12-plus hour overnight fast, is one of the most powerful liver protective habits on this entire list. Your liver operates on a circadian clock governed by the same light-dark cycle that regulates your sleep. Research from the Salk Institute and multiple chronobiology labs has documented that hepatic gene expression, the activation of liver enzymes for detoxification, bile production, glycogen management, and lipid processing, follows a precise 24-hour rhythm. Between approximately 10 p.m. and 2 a.m., the liver upregulates its detoxification enzymes and ramps up bile acid synthesis, preparing to process the metabolic waste accumulated throughout the day. When you eat a large meal late in the evening, you divert the liver's resources away from this repair and detoxification window and toward food processing. Digesting macronutrients, managing a post-meal glucose surge, packaging dietary fat into VLDL particles. The repair window is hijacked. A 2019 study in Cell Metabolism found that participants who ate within a time-restricted window aligned to daylight hours showed significantly improved liver enzyme profiles, reduced liver fat content on imaging, and lower serum inflammatory markers within 12 weeks. Japan's early dinner isn't about calorie timing. It's about returning the liver's night shift to the organ that owns it. Dashi, Japan's foundational culinary broth made from kombu seaweed and dried bonito flakes. It forms the base of miso soup, simmered dishes, noodle broths, and sauces across the entire spectrum of Japanese cooking. And the specific compounds extracted into dashi during its preparation make it one of the most gut-supportive foods in any cuisine. Kombu is exceptionally rich in glutamic acid, the amino acid that gives dashi its distinctive umami flavor. Glutamic acid is also a primary fuel source for the rapidly dividing enterocytes of the small intestine, supporting the rapid cell turnover that maintains the integrity of the gut lining. The intestinal epithelium renews itself every 3 to 5 days, one of the fastest cell turnover rates in the body. Maintaining that renewal requires an adequate supply of glutamine and glutamic acid to fuel the cells through their rapid division cycle. Kombu dashi is also exceptionally rich in iodine, magnesium, calcium, and trace minerals that support enzymatic function throughout the digestive system. Research published in Food Chemistry documented that hot water extraction of kombu released significant concentrations of fucoidan alongside mineral content, bringing seaweed's anti-inflammatory polysaccharides directly into the broth that forms the base of every Japanese meal. Japan doesn't drink bone broth as a wellness trend. They drink kombu dashi as ordinary cooking. And the gut lining, built from the minerals and amino acids that dashi delivers, is measurably different from one built on broth-free, ultra-processed meals. Matcha, the whole-leaf powdered green tea that delivers EGCG at 137 times the concentration of standard steeped green tea, and whose effects on liver fat metabolism are now documented in human clinical trials. Non-alcoholic fatty liver disease. The accumulation of triglyceride fat in hepatocytes is the most common liver condition in the world. It affects 100 million Americans, most of whom are never told. Its progression from simple steatosis to steatohepatitis to fibrosis to cirrhosis is driven by a combination of insulin resistance, oxidative stress in liver cells, and hepatic inflammation, all three of which EGCG targets directly. A randomized controlled trial published in the European Journal of Nutrition found that matcha green tea consumption over 12 weeks significantly reduced liver fat content and liver enzyme levels in participants with non-alcoholic fatty liver disease. EGCG activates AMPK in hepatocytes, the metabolic master switch, which directly inhibits fatty acid synthesis and promotes fatty acid oxidation in liver cells. It simultaneously activates NRF2, increasing hepatic antioxidant defenses that counteract the lipid peroxidation driving steatohepatitis. And it reduces hepatic NF-kappa B activity, damping the inflammatory cascade that converts simple fatty liver into the dangerous, inflammatory, fibrosis-prone form. Japan drinks a bowl of matcha every morning. Their liver biopsy data, and their dramatically lower liver disease mortality, reflects what a daily EGCG dose does to a hepatocyte over 50 years. Washout, Japan's traditional dietary pattern, recognized by UNESCO as an intangible cultural heritage, and the principle of variety that sits at its heart. Because for the gut microbiome specifically, the number of different plant foods consumed each week is emerging as one of the most powerful predictors of microbiome health ever identified. The American Gut Project, one of the largest citizen science studies of the human microbiome, found that individuals who consumed 30 or more distinct plant foods per week had dramatically richer microbiome diversity than those consuming 10 or fewer, regardless of whether they identified as omnivore, vegetarian, or vegan. The specific plants mattered less than the sheer number of different ones. Japan's washout plate, built around seasonal vegetables, multiple seaweed varieties, legumes, fungi, and diverse fermented preparations, routinely achieves this 30-plant threshold without conscious effort, simply by following traditional cooking practice. Microbiome diversity is not a cosmetic health metric. Research published in Nature found that reduced microbiome diversity is directly associated with increased intestinal permeability, higher circulating LPS endotoxin levels, elevated liver inflammatory burden, and worse kidney function outcomes in longitudinal studies of aging adults. A diverse microbiome produces a wider spectrum of short-chain fatty acids, maintains more complete competitive exclusion of pathogenic bacteria, and generates a broader enzymatic repertoire for processing dietary compounds into bioactive metabolites. Japan's washout culture feeds the microbiome with variety, and the gut, liver, and kidneys function better in every body that achieves it. Japan's consistently high fluid intake, through green tea, miso soup, dashi broths, and water. And the way this continuous fluid delivery maintains the kidneys in an optimally hydrated filtration state throughout the day. The kidneys require adequate fluid volume to maintain urine dilution above the threshold at which stone-forming compounds precipitate out of solution, to flush tubular waste products efficiently without concentrating them to nephrotoxic levels, and to maintain renal blood flow at a rate that prevents ischemic damage to tubular cells. Chronic mild dehydration. The baseline state of most Western adults who rely on thirst as their primary hydration signal, is a sustained low-grade stressor on renal tissue that, compounded over decades, contributes meaningfully to kidney aging and chronic kidney disease progression. Japan's food culture delivers fluid continuously and palatably throughout the day. Green tea with meals. Miso soup at breakfast and often lunch. Dashi-based broths in evening dishes. This habitual fluid delivery keeps daily urine output in the range, typically 1.5 to 2 liters, that research in Kidney International confirms is associated with lowest kidney stone recurrence risk and slowest GFR decline in aging adults. Japan doesn't count their daily water intake. They don't set hydration reminders. They drink tea and eat soup, and their kidneys operate in a comfortable, well-irrigated environment they were designed to work in. The oduro. Japan's daily hot bath ritual. And the connection between evening hot water immersion and liver function runs through a pathway most people have never considered, the skin as a secondary detoxification organ. Your skin is the body's largest organ, approximately 2 square meters of surface area, and it eliminates compounds through sweat including heavy metals, BPA, phthalates, urea, and certain drug metabolites. When the liver is burdened. When its phase 1 and phase 2 enzyme capacity is outpaced by the toxin load it receives, dermal excretion becomes an important secondary route of elimination. Japan's hot bath, maintained at 40 to 42 degrees Celsius, produces genuine thermal sweating, not the mild perspiration of a warm room, but deep dermal sweating that actively carries dissolved compounds out through the pores. Research published in the Journal of Environmental and Public Health confirmed that thermal sweating significantly increased the urinary and dermal excretion of heavy metals, with skin excretion often exceeding renal excretion for compounds like arsenic and cadmium, compounds that, when retained, accumulate in the liver and cause direct hepatocellular damage over time. The oduro also produces heat shock proteins. Molecular chaperones that in the liver specifically support hepatocyte protein quality control and help prevent the accumulation of misfolded proteins associated with alcoholic and non-alcoholic liver disease. Japan bathes every evening. The liver offloads some of its burden through the skin while the hepatocytes repair themselves in the heat. That is not a spa habit. That is hepatic maintenance. Japan's low consumption of added sugar and ultra-processed food. And the reason this single dietary difference may be the most hepatoprotective habit on this entire list. Fructose, the sugar in high fructose corn syrup, table sugar, and fruit juices, is processed almost exclusively by the liver. Unlike glucose, which is distributed to every cell in the body for energy, fructose bypasses normal metabolic regulation and is taken up almost entirely by hepatocytes, where it is phosphorylated by fructokinase in an ATP-depleting reaction that generates uric acid as a byproduct. Excess fructose arriving in the liver, as occurs with the 77-gram average daily added sugar intake of American adults, overwhelms hepatic fructose metabolism, promotes de novo lipogenesis, generates uric acid that damages liver cells, and drives the oxidative stress that converts simple fatty liver into inflammatory steatohepatitis. Japan's average added sugar intake is approximately 37 grams per day, less than half the American average. And Japan's traditional diet contains almost no ultra-processed food, no high fructose corn syrup, no hydrogenated vegetable oils, no synthetic emulsifiers. Research in the journal Hepatology found that fructose-restricted diets reduced liver fat, improved liver enzyme profiles, and decreased inflammatory markers in patients with non-alcoholic fatty liver disease within just 9 days of dietary change. 9 days. The liver responds that quickly when the fructose burden is lifted. Japan never loads that burden in the first place. And its near absence of liver cirrhosis-related mortality in population-level data is the result of that decision, made 3 times a day at every meal, for an entire culture. Ikigai, Japan's philosophy of purposeful living. And here's why this, of all 25 habits, earns the top position when it comes to liver, gut, and kidney health specifically. Chronic psychological stress, the kind produced by purposelessness, chronic overwork without meaning, or persistent anxiety, activates the HPA axis and sustains chronically elevated cortisol. And cortisol is one of the most organ-damaging hormones in the human body when chronically elevated. For the liver, cortisol drives hepatic gluconeogenesis and promotes visceral fat deposition, which delivers inflammatory free fatty acids to the liver through the portal vein, directly fueling steatosis. For the gut, cortisol increases intestinal permeability by disrupting tight junction protein expression, literally opening the gut barrier and allowing endotoxins to reach the liver. For the kidneys, cortisol activates the renin-angiotensin-aldosterone system, raising blood pressure and increasing glomerular filtration pressure in a way that, sustained chronically, causes nephron loss and progressive kidney aging. The Japan Gerontological Evaluation Study, tracking over 43,000 adults across 7 years, found that those with a strong sense of ikigai had significantly lower all-cause mortality and maintained better organ function profiles into advanced age than those without it. The mechanism is direct. Ikigai suppresses chronic cortisol, which reduces the hormonal cascade that simultaneously inflames the liver, disrupts the gut barrier, and hypertension the kidneys. Every food habit on this list. The miso, the green tea, the daikon, the fish, the fermented vegetables, is more protective in a body whose cortisol is calm. Japan understood this without a single clinical trial. They built purpose into the culture and watched 3 organ systems stay healthy for a century longer than anywhere else on Earth. Here's what every gastroenterologist, hepatologist, and nephrologist already knows but rarely has time to tell you in a 15-minute appointment. Your liver, your gut, and your kidneys are not independent systems waiting for separate treatments. They are an integrated filtration network, connected through the portal circulation, through the gut-liver axis, through the gut-kidney axis, and through the hormonal and inflammatory environment that your daily habits create. When one fails, the others are under greater stress. When all 3 are supported, your entire metabolic and immune system functions at a categorically higher level. Japan has built the support for all 3 into the fabric of ordinary daily life. Warm water to begin the day. Miso soup to seed the gut. Green tea through every hour. Daikon with fatty foods. Seaweed at every meal. Natto for the blood. Fermented vegetables for the gut barrier. A walk after every meal. Fish instead of red meat. Mushrooms in the broth. Defined meals with genuine fasting gaps. Ginger in everything. Diverse plant foods at every dish. Plant protein as the primary protein source. An early, light dinner to give the liver its night back. Mineral-rich dashi as the cooking base. Matcha every morning. Enough tea and soup to keep the kidneys irrigated all day. A hot bath to offload what the liver couldn't finish. No fructose overload. And a reason to wake up every morning that keeps cortisol calm enough for all 3 organs to actually do their jobs. These aren't 25 separate prescriptions. They are one coherent, mutually reinforcing way of living. A lifestyle that has produced the lowest rates of liver disease, gut disease, and kidney disease in the developed world, without a single pharmaceutical protocol and without a single specialty clinic. Pick one habit from this list. Start tomorrow. Then add another. Your liver, your gut, and your kidneys have been working for you every single day, processing everything you've put through them, without complaint. Give them what Japan figured out they need. And watch what happens when 3 of the most important organs in your body finally get the support they've always deserved. Comment below with the habit you're starting first. Share this with someone whose organs deserve better. Subscribe, because there is much more of this to come. Your organs are listening. Start the habits.